India's greatest challenge is to channelize its resources effectively so as to attain economic superpower status. Lack of data on resources and customer preferences hampers the understanding of the driving forces contributing to its sustainable growth. Accumulating data on diverse economic activities and converging them to develop, implement and monitor policies successfully can be achieved only by implementing an advanced technology like 5G. India addressed this problem with its scientific prowess and took the challenge of developing an indigenous 5G technology. Within a short span of 3 years, India has successfully developed 5G technology, aligning expertise from 3 IITs. A team of more than 100 engineers and scientists from IIT Madras, IIT Bombay and IIT Kanpur have designed 5G technology indigenously from scratch. All components and fabrication are entirely made in India, except the semiconductors used in it. 5G network comprises of 3 fundamental systems, namely remote radio head, baseband unit and 5G core. Now, let us listen to the team leaders who have developed these components.
You see a lot of cell phone towers. These towers generally have antennas as well as aluminum boxes which are connected to these antennas. A remote radio head encodes information into waveforms that are transmitted over the air, which your cell phones decode. 5G remote radio heads are a little bit different from what you are going to see in 4G. In 4G, the antennas are separate out from the remote radio heads, whereas in 5G, you are going to see an integrated box. We have developed 16 antenna, 32 antenna, 64 antenna remote radio head that are compliant to global ITU standards. This is a 16 antenna remote radio head that we have developed. It's an IP65 rated remote radio head that you can put on the top of a tower. This is completely passively cooled and it weighs about 16 kilos. This remote radio head takes minus 48 volts as its input power supply, which is an industry standard. It's also made robust to Indian voltage fluctuations. A lot of care has been taken in the design of this for EMI and EMC compliance. While this is currently designed for the 3.5 GHz band, all the things in this are modular. So the frequency of operation for this device can easily be changed. This particular unit is designed for the N78 band, which is a 3.5 GHz TDD band. Each of this antenna can transmit about 1.5 to 2 watts of power and it is dual polarized. Since it's a massive MIMO system with multiple antennas, you get an additional 12 dB gain. This massive MIMO system can support about 8 layers of MIMO at 100 MHz bandwidth. Additional RF circuitry has been built into this for TD calibration as well as DPD and CFR. This particular remote radio head can support 256 QAM. There is a possibility of GPS synchronization as well as synchronization through PTP. This remote radio head has DPD and CFR to meet the ACLR requirements of all the antennas. This RR has been integrated with the BBU and the core network and has been tested extensively at IIT Madras.
Baseband unit is the heart of 5G base station. It does bulk of the processing and it has to be designed accordingly. Unlike the existing 4G baseband units, which are designed as a complete box, we wanted it to be cloud radio ready. That's where the future networks are evolving. We have designed it as a miniaturized PCI card, which can fit inside a server and which can talk to the remote radio head using the optical fiber. That's how we have designed it. Each radio head can serve or pump out 40 gigabits of data. Each baseband unit can cooperate with each other to serve multiple remote radio heads to enable cloud radio architecture. Each such board runs primarily the L1 stack. The L2 and L3 stack are being run on the commercial off-the-shelf server. So each such board is designed to serve 400 megahertz of bandwidth. So it has multiple FPGAs. The software is compliant with the ORAN standard and it has been designed to serve industry standard 7.2 dot split. So it can support up to 256 QAM, can serve up to 20 users in a 0.5 millisecond TTIs. The baseband unit supports different data and control channels, for example PDACH, PUACH, DMRS, CSIRS. So this baseband unit has been completely integrated with the remote radio head, and the core network has been tested extensively.
The 5G core connects the radio access network or the RAN to other external networks. When a user connects to the internet for the first time, the 5G core registers the user, authenticates the user, sets up security keys, sets up sessions or paths for the user's traffic to flow from the base station to other networks, manages the mobility of the user. So all of this functionality is provided by the 5G core. So the 5G core is designed to have a cloud native architecture. The various components in the 5G core are built as software components on regular commodity hardware, not on custom specialized hardware, but on regular servers. Other aspect is that the control plane, or the logic that sets up the sessions, is separate from the data plane where the actual forwarding of the data happens. We have a few servers, we have a small cloud-like setup over here, and these servers are running the various 5G core components, the control plane components and the user plane or the data plane components, they're all running here. We have built our 5G core to have a complete cloud-native architecture. It has high performance. We have measured performance up to 40 Gbps and latency is under 1 millisecond. And moreover, our performance is scalable. If we add more servers over here, we're going to get more performance. And our system is also fault tolerant, and we also follow the service based architecture. That is, all of these components are modular and they talk to each other over standard HTTP REST APIs. The 5G core has been developed in collaboration with our partners in the 5G testbed project. It has been integrated with all the other components of a 5G network. This is an example of a secure indigenous core that we have built from scratch as part of the 5G testbed project.
Standalone, these three components are marketable too. The entire design is tested with industrial-grade testing systems in compliance with international specifications and standards. The current technological ready level, TRL, is 7, and soon it will be implemented in IIT campus to study the end-user experience. This indigenous design gives India an edge over its data security besides ultra-high speed with low latency. India's 5G is robust to accommodate additional security features customizable to both civilian and military purposes. With the advent of 5G technology, education, healthcare, agriculture, effective implementation and monitoring of legal framework, logistics, disaster management are some of the areas that will see unprecedented development in a short span of time.